Good morning. Thank you for joining us this morning on this really rainy day. We're super excited to have Jon Racek here to talk to you about design and how we can implement sustainability into our housing projects. If you have any questions along the way, please put them in the chat. If I think that it's a question that needs to be answered immediately, I'll pop in and let Jon know that we have a question that I think he needs to answer now. Otherwise, we'll save them to the end of the presentation. So please, feel free to let us know if you want to know anything. So Jon, I'm going to ask you to join me this morning, and I'm going to let you give our attendees a little bit of information about your background, and then you can feel free to go get started.
Sure.
Thanks again for joining us. Thank you so much, Jon, for doing this for us. I really appreciate it.
Of course. No, I'm happy to be here. And I want to thank you all for joining us. I know your time is valuable, and hopefully this will be a informative presentation for you all. So I'm going to share my screen, and I'll tell you a little bit about myself as we do this. Okay. So, all right. So again, my name is Jon Racek. I'm going to be talking about affordable housing, energy efficient housing, and give you sort of a broad overview of some of the interesting technologies and approaches and strategies that are out there in the world right now, as we try to develop affordable energy efficient housing, particularly in rural communities. So I'm a faculty member at the Eskenazi School of Art, Architecture and Design in Bloomington. I'm a senior lecturer in an area called Comprehensive Design. I'm also the program director. And I'm the founder of ServeDesign, which is a center here at IU that works to bridge resources from IU in the area of art and design with communities in Indiana. Before I came to IU, I practiced and was trained as an architect. I worked in Los Angeles, I worked in Boston, and some other places. I got into this area of rural housing through a project with the Center for Rural Engagement here at IU. And there was a group in Paoli that was interested in exploring ideas about housing and rethinking, potential opportunities within housing. There had not been any housing built in about 10 years in Paoli for a number of different reasons. And so we were kind of exploring why that was happening, and is there maybe an attempt to try to solve some of those issues. Now, as we all know, with housing, it's a very complicated subject. So I don't want to present any of this as a silver bullet to any housing issue. This is the design aspect, the building technology aspect, the planning aspect. These are just one small part of the larger housing problem. As we all know, it seeps into the economy, it seeps into politics, it seeps in, it is all encompassing. And I think that really is the way to try to solve the housing issue in the country right now. So the other thing I want to say is I'm not an expert. I'm just someone who's spent some time examining, analyzing some of these different building technologies. And so I'm sure there are people out there who have much more experience than I do. And I would love for you to reach out and continue this conversation after the presentation with your thoughts and your ideas, and let me know what I got right and what I got wrong. So with that, let's jump in. The project that we were doing in Paoli, we called it the Modest House Project. And what we were trying to do was balance affordability and energy efficiency. Now, affordability, as we all know, is also kind of a tricky term. What is affordable depends on where you're at. It depends on a bunch of different things. The energy efficiency portion, I think that was important to the community because one, climate change, and two, because the residents of Paoli, a fair number of them, are on fixed incomes, and they are, the energy efficiency was really about saving people money. And so that became an important part of our goal. And so over the course of a couple years, I spent some time looking at different ideas of how to build more efficiently, how to build more affordably. And we looked at a number of different things. Concurrently, I was also working with some developers here in Bloomington who were interested in trying to solve affordable housing on a larger scale, creating small scale developments. And they were also looking to have me do some research on other ideas, other options than maybe more traditional neighborhoods. So that's what I did, and that's what I'm going to cover here today. So just a short snippet about the challenge of rural housing, and all of you presumably are in the area of housing, so you know a lot of this, but couple different points: lack of funding, high development costs, a limited workforce, and then lower demand than maybe more suburban or urban areas. The other one that I would add to this is, for Paoli, what we encountered was there were builders in that area, but they could make a lot more money in Bloomington. So there was this sort of unequal balance of, or Bloomington, I guess, was a bit more financially incentivized to get housing than a place like Paoli. So I'm going to talk about two different scales. I'm going to talk about sort of a neighborhood scale, ideas and innovations and strategies for developing neighborhoods, and then a smaller scale in terms of maybe directed towards builders and ideas about building technology. So we'll start out with the sort of larger scale. 5 different things we're going to talk about. First is sort of the tiny house movement. Okay, tiny house movement is pretty interesting. It's developed in some interesting ways across the country, and these span from Airbnb, cute little rental units, to things like housing for the homeless populations. And there's some different examples. This here is in Missouri. This here is in Los Angeles. And there's some interesting responses using the sort of tiny house idea. I think one interesting thing that's happening here in some rural areas is the idea of a tiny house development replacing mobile homes. And I think there's some interesting examples out there of people taking down maybe decrepit mobile homes and replacing that with tiny houses, both sort of as rental units. I think there's some benefit to this. The one idea is that you're able to replace old units which are hard to fix, and people, communities are trying to move away from that kind of housing typology. So I think that there's some interesting ideas there. Tiny housing, there's some pros and cons to this, and I've tried to list pros and cons for all the different areas that I'm gonna talk about. I've not really spent any time living in a tiny house, but I have a friend who has, and in the beginning, it's a pretty interesting idea, but you quickly realize how small it is. Not really great for families. There's some market resistance, but in some ways, for certain people in certain phases of their life, it can actually serve as a really great alternative, particularly people who are downsizing. Maybe they're older and they want they're getting rid of their stuff anyway, and so the tiny house provides an opportunity. And the tiny house is kind of a moniker that can be applied to lots of different things. You can apply it to little A-frames like this. You can apply it to very small little units, as we saw in some of the previous examples. So there's a lot of I think it's under 600 feet is maybe what someone has defined a tiny house, but really it's about how do we build smaller. How do we maximize our space? How do we be thoughtful about our space? I do think that there's some potential in terms of, can can we maybe apply some of the other building technologies that I'm going to be talking about? Can we build these in a factory? Can we sort of maximize energy efficiency through thoughtful wall assemblies, things like that? So I think that there is some interesting potentials with the tiny house movement. Again, some of these are trends, and some of these are sort of things that pop up in design and residential focused magazines. And we can wonder about their staying power, but I do think that this is a pretty healthy movement in terms of density and in terms of rethinking sort of the quote unquote traditional American house. The second thing I'm going to talk about is called co-housing. Some of you might be familiar with this. This is a intentional collaborative neighborhood that combines private homes with shared indoor and outdoor spaces. So this is a movement that's been around for a while. I think in the beginning it was maybe a descendant of some of the intentional communities that we saw. Actually, we've seen throughout American history. We had a lot of those at the turn of the century. We have a lot, we had a lot in the 60s. But this is an idea about providing, maybe presenting a different way of living together, where a group of people will, and sometimes this is a brand new development, a group of people will get together, sometimes with a developer, sometimes without a developer, and maybe create smaller housing with shared facilities. So in this example, you can see a playground here, you can see a garden space, you can see a common house. These common houses traditionally have some sort of dining facility and some sort of kitchen. So it becomes a communal space where, and I've read about co-housing neighborhoods where people eat together every night. Sometimes, or sometimes it's more like what you might see in a more traditional housing development that has a common space where people use it for special events or things like that. And so I think the co-housing model can be, has lots of different variations. And people are sort of developing this idea in lots of different ways. Again, just another, some of them are larger scale, three-story units. A developer can really sort of pack in some density. Because it's an alternative to maybe a more traditional housing typology of sort of dense units. You're getting something more from this. You're getting that common space. You're getting those shared facilities. And there's also something about governance that's a little bit different than maybe a more traditional development. Sometimes people will write in how decisions are made for the whole development. And again, this can vary. Sometimes the expectation is that you're very active in the governance of the commons, or governance of how things are working within the co-housing development. And then other times it's a little bit more hands-off. So it sort of ranges. So some pros and cons. There's an opportunity for density. Again, people I think are a little bit, because they are interested in a community, that's what attracts them to the co-housing model. I think people are a little bit more maybe open to density. There is a sort of a built-in community, and that can be attractive for people who are aging in place. And this is another obviously massive topic that we as Americans are facing as well, particularly in rural communities, as well as other countries in the West. So this co-housing model allows for that so that community, people are looking out for each other, and that aging in place idea I think works well, aligns well with the co-housing model. Some things that I've read in some research paper is people complain about too much democracy, right? This idea of let's all get together and make some decisions, maybe a death by community kind of approach, or death by committee, I mean, not by community. And then it can be hard to implement, right? If you're getting a bunch of people together, making decisions, having that sort of very democratic approach can lead to some delays. And so, I think in the beginning, that was the model where everyone was sort of having a lot of input in how things were developed. I think you see a lot more developer-driven co-housing models now. There's a co-housing development that was just created here in Bloomington, and that's sort of in the early years. And I'm interested to watch to see how that grows. The next idea that we're going to talk about is ADUs, and this is maybe a little bit less about neighborhoods. A little bit more about how do we increase density or insert housing in places that they might not exist. This is probably mostly known in more urban areas, or small cities like Bloomington. We've passed an ordinance allowing for ADUs, I believe. And so this idea has been around for a long time, the granny flat, the garage unit, and it's about how do we insert small scale housing on single family lots. One thing that I personally believe is that if we're going to solve the housing issue in America, we need to think beyond the single family house. It's a model that worked for a long time. I don't know if it works anymore. And I think that the housing prices are partly an illustration of how unsustainable that model is. So the ADU is it's a way of inserting a little bit of density into a traditionally single family landscape, and it's done in a way that I think has a bunch of pros. One, again, it allows for generational housing. You can bring in your parents, your elderly parents. You can set them up into their own space, but they can also interact with the family. They can provide childcare. You can watch over them, make sure that they're okay in terms of emergencies and things like that. There's potential for rental income. We've seen Airbnbs, we've seen rental units. Sometimes municipalities are a little bit hesitant to implement that. Bloomington, I think that they're trying to maybe prevent some of that. I don't exactly know where that is. But other, in Los Angeles, this is becoming a major technique for building density into a city that traditionally had a lot of single family lots. So that extra income is a big motivator for building these ADUs. Privacy is an issue. If your garage is now an ADU, you've lost some storage. But I think that, in my opinion, the ADU movement is a really strong idea. Even I think in rural communities, potentially you have larger lots and homes that maybe people who are aging can't take care of, and so the ADU building another property on the lot makes some sense in my mind. The next thing I'm going to talk about is called incremental housing, and this is an idea that has developed less so here in the U.S., though there are some examples of this being implemented, maybe not in the way that I'm going to talk about. This was developed by an architect in Chile, and he was looking at social housing. And essentially, what you're doing is you're building kind of the shell, and then you're building half of the house. And the half of the house that's being built has sort of some core functions like bathrooms and kitchens and your mechanical systems and things like that. The idea here is that you are, over time, able to build out the second half of the house. Now, you might do that because you can't get traditional financing. You might do that because your family, initially your family is small, and you might grow into needing more space. And so another kid comes along, you build out another side of the house, and you start building bedrooms. It might be a aging in place technique as well. And so, it might not look like this in the US. It might look very differently. I know that in houses that I design, I always try to insert additional plumbing in the walls so that people can add an additional bathroom if needed. And so I think that there's an idea of let's sort of set the stage for growth. in a house, even though right now you might not need that. So there's some interesting examples. Again, this is mostly in areas that look a little bit different than the US, maybe developing countries. But I think that this is an idea that is has real potential to be brought into the housing conversation in the United States. So you can see on the left there, they've built some units, some small units, but there's space to the right where they can fill it out. Some of the pros and cons about this, there is maybe a hard acceptance. The market might not accept this kind of dramatic type of incremental housing. The idea that the house might not be unfinished, that would probably be pretty unappealing to a large neighborhood. But some of the pros are that it allows for incremental growth for a family. This idea of generational housing again. Maybe it's a DIY approach where if you build the major systems in a house, that someone who's a bit handy can finish the house themselves. So I think that there's some potentials there. I think it's an interesting model that should be explored. Then the other example that I'm going to talk about is the container. And this is a little bit less about sort of neighborhoods, though there are examples of neighborhood communities or container neighborhoods out in the US. This has been sort of, I think in my mind, kind of a trendy idea for a bit. Personally, I think it's not a very good model. And there's a lot of reasons for that, which I'll explain, I think. I think it's there is sort of a misconception or a myth that this is really a cheap way of building. I also would argue, I would push back against that. So some of the reasons that I would push that I think this is not necessarily a great model, but I felt like I needed to include it. First of all, the structural problems that are inherent in the containers. The containers are engineered for containing all of our stuff that we get from all around the world. It's engineered for stacking. But once you cut into the side of those or sort of break the skin of this container, you have to reinforce that. The container kind of fails after that. And so you have to come back and you have to add some structural reinforcement to that. There are some examples here that you can remove the doors and add them in without having to do a lot of structural work. But in some of these examples where you're poking windows in, all of this had to be reinforced. This here in particular, that needs some additional reinforcement because you're basically taking the skin off. I also wonder about, if you're thinking about a neighborhood of this and it's mixed aesthetics, how appropriate is that? Do you want to be living next to a container house? The head height of these units, there are some taller units that you can get, but oftentimes they're pretty small in terms of head height. And once you put in your insulation, that head height even gets smaller. They are affordable as units themselves, but the work that I think you have to put in to make them livable requires a pretty decent investment. Sorry, this should say containers, not co-housing. They are stackable. They are modular, and so that does have some benefits. It's hard to put in an interior staircase with these. So if you're stacking these, 4 or 5 levels high, you have to think through how do you add the circulation. There are some interesting examples in the Netherlands of developers using container homes. What's worked there has been student housing, providing maybe cheaper student housing. Students maybe are more interested in living in a space like this. So it has had some success in Europe. I'm not sure. I've seen individual one-off houses. There's some interesting examples. This one here, basically they've created a shed, and then they've placed the containers as rooms within the space. So there's some I think that there are some interesting models out here, but I don't know if this is a great sort of potential widespread solution for our housing issues. Okay, I'm going to get into a little bit smaller scale, maybe talking about some building technology and building techniques. There's about 4 or 5 here, or maybe 5 or 6 that we'll talk about. We'll first start with SIP panels. So SIP panels are structural insulated panels. And they consist of 2 pieces of typically OSB boards, and they sandwich a large block of foam, EPS or GPS foam. And so the image on the left shows you sort of the assembly of or how these panels go together. There is usually some sort of spline joint that connects the 2 panels together. As I understand it, there are 2 ways that these panels are delivered. Sometimes they're just delivered as massive, as large panels, and you can cut the openings. Other companies will offer a service where they are cutting openings for you, and then that's being delivered to the site with everything sort of set up. As you can see, these can be used for walls, they can be used for floors, they can be used for roofs. Obviously, they're pretty large, and you need a crane to make that happen. So some pros and cons. In terms of energy efficiency, you can get some really great energy efficiency with these units. There are less seams. You know, you're building in your insulation. You know, you can get 40, 50 R value in some of these walls. So it has great value for high energy efficiency. So what I mean by that is if you're trying to build in a very energy efficient house, this has great value versus sort of a stick built house where you have to then try to get to that 40 or 50 R value. So if that's your goal, then this is a great solution. Is it a great solution for everyday small scale housing development? I'm not sure. I think it's a little bit, you know, it's when you put it up next to stick built housing, I think is a little bit more expensive. Great structural integrity, produces less construction waste. Little room for improvements after you've set your design. It's hard to make changes. It's possible you can cut openings and things. Oftentimes the electrical chases are already sort of set in the panel, and so there is a lot of this being built out in Colorado, in the mountain states. This is a very popular way of building out there. In the Midwest, I think it's a little bit less known, less accepted. There are some companies in Indiana who do it, but I think it's maybe a little bit slower to be accepted here. And then transportation obviously is you know, an additional cost. Next is this idea of panelized construction, and this is more of a kind of a general approach. Essentially, you're building your walls in a factory, and there's a lot of benefits to this. You can, and this can vary from just the framing to more of a finished wall where drywall is put on. So again, it's built in a factory, so there is efficiencies built into that. You're going to save some time. There's fewer weather delays. Transportation and, you know, hiring a crane, that's all going to be necessary to implement a building like this. Quality control is much better in a factory environment, of course. So there's a lot of benefits to this, and I've seen some really interesting models out there where people are using panelized systems. There's an interesting nonprofit that's doing affordable housing where they are building. They're getting volunteers to build these panelized walls and then they're shipped and put up on site. So, you know, the labor, it's part of the difficulty in saying whether one thing is cheaper than the other is there's a lot of factors that have to go into it, right? So, you know, with stick-built housing or stick-built construction, you can get your lumber from Menards or Lowe's or Black Lumber or wherever. You just need a saw. You need, you know, some simple tools. It's easy to do. People have been doing it for years. You don't need any specialized equipment. So, you know, we're trying to provide some alternatives to that. But when the question comes up, what's cheaper? It's not an easy answer. So you have to kind of look at the holistic. You have to take a holistic view of that question. You know, are you right now in Indiana? We are trying. You know, we have a skilled labor problem, and so, you know, some of these other systems might provide an alternative to that. You know, if you can find a factory that's going to put up put together panelized systems for you, and you know, crane and transport's not a big deal, then this might be a lot cheaper in the end. You know, weather is an issue, you know, labor, all these things sort of come together, and they have to be part of your decision-making process when you're comparing building technology. Let's talk about modular. Modular also is a little bit like panelized system. You're building potentially whole units or portions of a building in a factory system. All the same benefits. Lower labor costs, saves time, no weather delay, lower waste, better quality. It's a front-loaded design, so it's hard to make changes on site. You have to transport it. You have to use a crane to get it together. Sometimes communities are less, they're hesitant to accept this kind of construction. And so that's, but I think that this, depending on the scale of what you're talking about, this has a lot of benefits. I think you typically see this housing developments, sort of large scale apartments, things like that. Next is insulated concrete formwork. Some of you might be familiar with this. Essentially, this is sheets of foam connected with a plastic webbing. You stack them like blocks or Legos, and then you pour in your concrete. So everything is sort of built into the system, which is really quite nice. I've become recently a big fan of this system. It allows for quick installation. You can bring in people who are pretty unskilled to put these blocks together. We did a house actually the house in Paoli. We used this system. We used this system because lumber costs were so expensive at the time. So and the people we were working with had some experience with this, and they had nothing but great things to say about using this system. So we worked with a high school in Paoli, and they were the ones who actually built the house, and they were able to easily, stack up these blocks. They were able to put together, the foundation and the first floor really, really quickly. So lots of benefits to this system. The insulation is great. The acoustic value is really great. The walls are incredibly strong. Again, a great value for a high energy efficiency house. Some of the problems with this, it's inflexible. If you want to make an opening, you're going to have to cut through a lot of concrete. So future remodeling has to really be thought through from the very beginning. Other issues with this is sort of carbon footprint of concrete is pretty bad, and I think the world really needs to move away from heavy concrete use. But I think all in all, this is a really great system to adopt. Again, a lot of builders are just used to stick-built. Still stick-built construction, but these alternatives really, I think, deserve a chance. Next, post-frame construction. This is your pole barn, I've spent a lot of time kind of looking at this as a model for construction, for residential construction in a rural area. You see the barn dominium trend that's happening, where people are using this as the post frame construction as a residential model. And there's some interesting examples out there in the world. So if you're not familiar with this building technique, essentially you're using trusses, you're using posts, you're using less concrete. You can pour a slab, and then you just have a series of footers. And there's even ways to minimize that concrete use. Then you are using some strapping. It allows, because the posts are bigger, it allows for a lot of openings or space for insulation. So this can be a high, you can achieve some great energy efficiency with this model. This allows for really large spaces. It allows for you to create a shell. We talked, I'll move to our pros and cons here. We talked about that incremental approach of building portions or allowing for flexibility, allowing for growth in your building design. This allows for that. You can build the shell and then slowly build out rooms as you need them. Because all the interior walls are not going to be load bearing, it does provide some flexibility. You can change things up as you need. So it's a shell that is your big initial cost. Market acceptance is, I think, getting better. I think that there's I've talked to people who work in, say, Boston. Their building codes, their permitting offices would never allow this, but I think that there's a lot more acceptance in rural areas. I think partly because people are familiar with pole barns, right? And so it's a small jump from pole barn into house. Quick construction, like I said before, it can be very energy efficient. It's difficult obtaining a mortgage for this kind of construction sometimes. And the resale value is, since it's a new construction or construction model, it's, people have complained about the resale issue. Building codes, it can be challenging as well. So there's some regulatory, there's some bureaucratic or some issues that you might have with certain municipalities for building this, but I think that there's a lot of value to this approach. And then something that's a little bit further out there is 3D printing housing, and this is this is definitely one of those interesting trends that are out in the world. I think it has some pros, and I think we'll probably see a lot more of it in the future. Right now, I think it is definitely a trend. I think people are kind of enamored by the technology. I think over time, as with a lot of this different technology, we will see how it really plays out as a practical and affordable model. So if you're not familiar with this, essentially, you're using a concrete slurry with a massive gantry. You can see that here. And the gantry basically moves the printing head based on a computer model. So there are some really interesting design potentials with this model where you can really design some interesting forms, and the 3D printer will print that. Less labor is needed for something like this. It's a pretty quick way of building. Again, there's not a ton of examples out there in the world that allow for where people have been doing this. There's a big development that's happening in Mexico right now. There's a development outside of Austin, Texas, where they're putting in a neighborhood of these. There's issues about codes and permitting and access to technology. There's just a couple companies out there who are doing this. There's a potential for marketing buzz, right? Doing a development of 3D printed houses is going to get you into newspapers and magazines and things. On the environmental side, because you're building with concrete, because there are ways to incorporate insulation as you build, the energy efficiency of this system is pretty good, is pretty high. And there's, again, things like reduced construction waste and stuff like that. So it's an interesting system. I think we will see more of it as we go forward, particularly in areas where labor is a real issue. So I made this chart. It's a little problematic because of this idea of affordability, as we discussed. It's really a complex equation to figure out where affordability lies. But if you were to map affordability over energy efficiency, this would be my thoughts. And again, I'm not an expert, but I did look with our Paoli house. I did look at lots of different systems, and we compared different systems using the same plan, and we actually got quotes for different things. So I guess I would qualify this chart by saying that this is not a researched, this is not something that's coming out of research, but more sort of my own experience. So I would say post frame is probably going to be the cheapest. Panelized systems can be very affordable, and you can build in that energy efficiency. 3D printing probably a lot more expensive because it's such a new technology. SIP panels and ICF, both high energy efficiency, affordability, a little bit more as an upfront cost. But again, if you're looking at a holistic approach, it might actually be cheaper in the end. So, and then the last thing I'm going to talk about is maybe a little bit more conventional building techniques, small things that builders can do to make things more affordable from the design point of view, that hopefully will have some impact. So this is really about design. And these are some of the things that we really did a lot of research on as we tried to build our house in Paoli. We wanted to make sure that it was a simple project. We wanted to keep things very sort of simple. Every time we added a corner, you're adding a lot of money to your project. So the floor plan had to be very simple. The roof had to be simple. The foundation had to be simple. And you'll see in some photos in a little bit that I think that we tried to create what I think is a nice house. It has a lot of nice design aspects to it, but it's quite simple. We started designing on a grid. We used a 2-foot by 2-foot grid. We were very strict about that. This is a technique that Frank Lloyd Wright used when he was doing his some of his modular housing that he came up with. And so this was, I think, pretty helpful for us. We tried to keep everything on that grid so that materials, all your materials come on 2-foot intervals for the most part. And so it allows for less waste, and we were able to maximize material costs or maximize materials and saving some money in the end. We looked at vernacular, sort of traditional architecture as a inspiration. I know here in Bloomington, there's a lot of old bungalows, which are again quite simple in their design, but they have nice little details, front porches and shutters and flower boxes and little things at the front of the house that add some appeal. And they're typically smaller. And there's a reason for all this. There wasn't some architect obviously out there who was designing bungalows. They were builders, and there were kits, and there were plans out there, and there was sort of conventions, and that drove a lot of these decisions. But they suited the needs of the population at the time, which was a nice, comfortable house for a family. I think the trend obviously has been bigger and bigger houses. I think we have to move away from that. I think it's just not sustainable, particularly because families are getting smaller, houses are getting bigger, families are getting smaller. And, we're going back to that density versus a single family model. I think that there's a lot of argument to move away from that again. So another approach that we had was we had a very holistic approach. We brought all our subcontractors together from the beginning to plan out the building. We went over the plans together. We saw where were the redundancies and where were the opportunities to make things cheaper. How do we design so the mechanical systems are the most efficient? How do we minimize ductwork? How do we work with the electrical so that we are, using less lights or whatever? So all of that was really important to saving costs in this project. Foundation, we did not do this in our modest house project, but this is a system that I have had a lot of interest in, and I've talked to a lot of people who've done this. And this is using the frost protected shallow foundations. So this allows you to use a slab foundation and to not dig really deep footers. What you're doing is you are using this sort of beige here is foam insulation, and you are creating these wings that spread out from the house, from the foundation. And what that does is there's heat loss from the building itself, and that heat loss actually raises the frost line. So minimizing the need for deep footers. So I think that this has got this is both an energy efficient and a cost saving approach. In terms of framing, yes, a single 2x4 stud wall is probably the cheapest option, but balancing energy efficiency and affordability, I think that the double 2x4 stud wall is a great approach. It allows for more insulation and it prevents a thermal break. Yes, it's more lumber. Another approach, and if that's an issue, is the optimum value engineered framing, essentially, which looks at traditional framing and says, what can we remove? What is redundant in that system? So, for example, removing one of the top plates, just have a single top plate, using a single ply header over windows, removing some of the redundant framing, and you're saving wood. So that's another. This is also called advanced framing. This is another way to save lumber in framing costs. In terms of materials, this is obviously much larger conversation. We chose materials in our project. We tried to have quote unquote green materials, but this is a complex conversation in and of itself. I talk to my students all the time about bamboo flooring. This is kind of the villain that we talk about when it comes to green materials. Bamboo flooring is made from bamboo, obviously, and bamboo is a grass. It's a fast-growing material. However, it's filled with resin, which is made from oil, and it's shipped from China all the way to the U.S. So if you look holistically at your materials, a local wood from Indiana is actually a much greener project than something like bamboo flooring. And so I think that we have to, as designers and builders, we have to think through what makes the most sense in terms of materials, and in terms of value, and in terms of environmental sustainability. In terms of mechanical systems, you may have heard more and more about air source heat pumps. These have been around for a while, but I think they're gaining a lot of new attention, particularly as we deal with the climate. And this idea is essentially the heat pump absorbs heat in the wintertime from outside and releases inside. And conversely, in the summer, the heat pump acts like an air conditioner and moves heat from inside out. So these are incredibly efficient systems. There's lots of incentives out there. Biden's Inflation Reduction Act, which is really a climate bill. They're providing lots of incentives for heat pumps, replacing inefficient oil furnaces and things like that. What was old is now new again. Passive heating and cooling, which was a system developed in the 70s. This to me is a great balance of energy efficiency and affordability. It doesn't require a lot to think through your siding, think through your location of your windows, building overhangs, thinking about thermal mass on your first floor. And so if you're not familiar with passive heating and cooling, essentially the way it works is in the wintertime when the sun is low in the sky, you have windows on the south facing side of your building. And in the wintertime, you get a lot of that winter sun the thermal mass picks up that heat and slowly releases it at night. So the density of that thermal mass allows the heat to be released slowly. In the summertime, the sun is higher in the sky, and these overhangs prevent solar gain into your house through these windows. And so these overhangs are really important. And we use this a lot in our project. So here are some images of the modest house. Again, you can see it's quite modest, but there's a lot of thought that went into it. Simple design, simple materials. In the interior, this is a shot of the main space as you walk in. There's a little kitchen here, high ceilings. And so you have, even though it's a very small footprint, about 1,700 square feet, even a little bit less actually, it feels big. You have high ceilings here. You can see how high the ceilings are. We've tucked a little bedroom in the back, which you can see here, sort of small spaces, really not meant for doing much more than sleeping. So we're trying to draw people into the big open spaces, the communal spaces inside our house here. On the south side of the building, we have lots of big windows, doors with windows, and we have some some overhangs. They're not quite as deep as I wanted them to be, but we had to do what we had to do. But there's a lot of great light in this house. There's a construction shot, and you can see the insulated concrete formwork that we used, the ICF blocks, and I wanted to show you how that looked. So because it's all concrete. It is a very quiet house. It has great energy efficiency. And at the end of the day, we built it during, some of the real major price hikes in construction materials during the pandemic. But overall, we were really pretty happy with where the cost came in. So there's a lot of conversation happening about how do we balance energy efficiency with affordability. A book that just came out recently called A Pretty Good House is a great book if you're interested in this topic. It's sort of a sensible approach to how do we create energy efficient houses without spending thousands and thousands and thousands of dollars. And it's really it's written by builders and architects, and they provide a very sort of practical approach to building what they call this pretty good house. And then I guess I will finish up with this quote from William Morris, who's a hero of mine. Have nothing in your house that you do not know to be useful or believe to be beautiful. So I think that reflects this idea of how do we create beautiful housing that serves as wonderful homes for people, and yet make sure that they're being responsible to and sustainable. This is my email address. I'm happy to continue this conversation. I'm happy to hear your thoughts on some of the different technologies that and approaches that I've presented here today. And I'd love to hear more of your experiences about what works and what doesn't work, if you have some experience with some of this technology.
Thanks, John. Really appreciate it. We do have some questions. So are you ready?
Yes.
Okay. So starting at the beginning of your presentation, when you were talking about tiny houses and ADUs and incremental housing and stuff, how do you determine whether or not any of those housing types are allowable in your jurisdiction? Are there going to be zoning considerations or building code considerations that we would need to look at before we decided that we were going to go with one of those new types of housing?
Yes, I think it's always beneficial to start conversations with your planning offices, your municipalities, and tell them what you're interested in doing, and tell them what your goals are. Those aren't necessarily going to be always easy conversations. People are always hesitant to see change, but I think the larger housing conversation in America is hopefully driving some new thinking about how do we solve this problem. I think that you'll be pleasantly surprised hopefully over time, that officials will maybe be open. They'll probably have to jump through a bunch of hoops proving your case. But there are lots of precedents across the country where all of these building technologies are being implemented. 3D printing probably is the newest one, but all of the other ones, there's precedent that you can draw on, and you can make a good argument.
Thank you. And then one of our attendees was inquiring about where you would find manufacturers for your insulated concrete frame work that you did. And you did that in Paoli, and I was actually in that house. And it's a very cool system that you had going there. So do you want to talk about how you found
Sure,
to do that? How hard was that? Because as I recall, the students built that house. They
did. So this was Jon Schellenberger, who works at the, I'm not going to get it right. It's a building program out of the Paoli High School. It's an incredible program. He's done an amazing job with these students. And so every year they build a house. And this year we were able to convince them to work with us. So yes, it was built with the insulated concrete formwork. After the house is built, you cannot tell that it was built with concrete or with formwork. There's no indication that and that's the case with most of these technologies. SIP panels, you wouldn't, after that, the siding is on, the drywall is on, you have no indication that this is anything but normal construction. The company that we used, it was called Fox Blocks. There are a lot of companies out there. I think Fox Blocks is in the Midwest, and so that was part of the reason we used them. But it's a really simple system. There are ways. There are things embedded in the Fox Blocks that allow you to hang siding and to hang drywall. And so you're really putting up the blocks, you're pouring the concrete, and then you're adding your siding and you're adding your drywall in the interior. So it's a pretty inclusive system.
Yeah, actually, I remember when I was looking at it, it looks like almost like Legos.
Mm-hmm.
Like it's put together, like Legos. I thought it was very interesting. And that house was really awesome, by the way. And you're right. It from the outside, it looks kind of small. And then you go in and you're like, wow, this is really big on the inside. I had no idea. So last question. We talked a lot about, energy efficiency and material waste and those kinds of things. But the one thing that didn't ever come up is LEED. Okay. LEED. So what are your thoughts there? I have some very strong thoughts, but we'll talk about that.
I have a lot of strong thoughts too. Okay. So LEED is, and this may seem controversial, but LEED is kind of a marketing tool. It's a way for companies, institutions to talk about that they value green building. Now, there's it's changed a lot. I'm actually LEED. I'm a LEED accredited professional, and so I'm pretty familiar with it. It's changed a lot over time. I think they've gotten better. They responded to a lot of the criticism, but there are. It's a way. It's based on a point system. You get certain points for doing certain things. At the end of the day, is that like, are we really being impactful with our decisions? In some cases we are, but in other cases, it's really about just getting the points. I know of a building, I won't mention where it is or who built it, but essentially they put in showers that didn't, the shower heads didn't work. They weren't hooked up to plumbing, but they did that so that they could get a certain amount of points for, people are biking to work, they have showers to get ready before work. So it was really a ploy. It was a ploy just to get the points, and it was never really used as intended. So it becomes a little bit of a game. Are there other systems out there? I think there are some really there are new accreditation systems coming on board. WELL is one that's focused on wellness. Living Building Challenge is another one. Passive House is a great one. So yeah, I think that there's ultimately, it's probably a good thing to show that people and people are committing to the LEED point system. But at the end of the day, is it the most impactful? I'm not quite sure.
Yes, well, actually, I did a lead certified housing development, and you are right. It's a marketing tool. I think at that time it was a really good idea because it really made us think about how to bring together all of these aspects to
Yeah.
put into a development. I think you're right that there are a lot of things out there nowadays, and the EPA has one too, isn't it? Isn't Energy Star kind of
Yeah.
beyond appliances and windows and doors now on the
Yes. Yeah.
website?
And that's actually probably the most reasonable one to achieve. That it's sort of they've made that very accessible to people. The other problem with LEED is that it's a lot of money to actually get accredited. So there's consultants and there's a lot of paperwork, and it's about $25,000 at least it used to be.
Yeah, it was not cheap when I did it either. So, okay, well, do we have any additional questions? Because that was the last one that I had. All right, it doesn't look like it. So I want to thank you so much for joining us today and talking about these kinds of developments and building techniques. Really appreciate it. Again, it was recorded and we will be posting it on our website probably next week. If you've missed any of our previous sessions, you can also find those on the ROI website, and the link to that has been posted in the chat. So look forward to some of our upcoming ones. So I'm not going to announce them today, but we're working on a couple ones that I think will be really interesting as well. So again, Jon, thank you so much for joining us today. I really appreciate it. Thank you all who attended. And again, it will be posted as a recording, and please feel free to share it with whomever you want, whether they're in the Indiana uplands or not. So thanks, and everybody have a great day. Thank you, Jon.
Thank you.